It's never good news when there's a leak in a radioactive waste tank. In this case, it was a double-shelled tank, and the leak was contained by the outer shell, resulting in no release to the environment. The remainder of its contents was moved to another tank. Waste is managed in these million-gallon steel tanks until it can be safely disposed after retrieval, treatment, and immobilization. As the tanks approach their design life, verifying their structural integrity is critical for continued protection of the environment and advancing cleanup. Building new tanks today would cost at least $250 million each, taking money away from efforts to retrieve and treat the waste. Pacific Northwest National Laboratory leads efforts to develop and qualify advanced methods for extending the life of Hanford's tanks in support of the Department of Energy and Hanford's tank operations contractor. The bottoms of the buried tanks are 50 feet below ground and mostly inaccessible for visual inspections. But PNNL's non-destructive evaluation experts have developed flaw detection requirements and the methods to qualify novel inspection systems for tank bottoms. After identifying promising technologies, we constructed large mock-ups of the tank bottoms. Our researchers are working with vendors to test and qualify industrial sensors and robots to inspect and detect flaws that, in a real tank, might require mitigation. A specially designed ultrasonic sensor uses sound waves to inspect wide swaths of the tank bottom to locate anomalies in the metal. This sensor, developed by Guided Wave, was adapted and miniaturized for under-tank inspection. Half the battle was getting it through an opening the size of a solo cup into the small spaces between the inner liner and outer shell. A small robotic crawler had to be adapted to carry the tethered sensor. Like this mock-up, the inner shells of Hanford tanks sit on a concrete base, with a network of cooling air slots providing the only access to the underbelly of the tank. The technology package has successfully identified spots where the team intentionally created pits, thin areas, and degraded welds. Meanwhile, PNNL scientists are developing machine learning algorithms, which will help operators better interpret the data acquired from the tank bottom to determine if an anomaly is an actual flaw. PNNL is also investigating an existing process called cold spray that may repair flaws in the tanks when identified early by the sensors. PNNL scientists and engineers are developing ways to implement the technology where powdered metal is sprayed at supersonic speeds onto the outside of a flawed area. The powder bonds tightly to the liner and increases the thickness of the metal to extend tank life. By using these advanced technologies to inspect tanks and detect and repair flaws, PNNL can help inform risk-based management decisions. If tank integrity is at risk and can't be fixed, the contents would be moved to another tank. But our goal is to extend the service life of current waste tanks to prevent leaks and continue to provide science and technology support to Hanford cleanup and waste processing.